guys, and welcome to part 5 of making this hit and miss engine that I'm going to do, or I'm doing. In this part I'm going to do the top hat liner, the cast iron bore if you like, that accepts the piston. As you've seen, we've already done the conrod, which turned out absolutely superb. We've done the main cylinder, we've split the crankshaft halves, and we've machined down the timing gears. By the way, I think the guy's name is one of my subscribers, Alan Tier. Thanks Alan, damn good idea. Right, so I was talking about machining a camshaft on here, and then I decided not, because it could be up to 4.5 degrees out in any tooth, you know, direction. So I wanted a cam that would rotate, and I was talking about taking away all this material, and then I talked about that there could be wobble in it if I did that. My plan was to make a cam, and in here to cut 2 holes and slot them so that I could fit the cam with 2 screws, and I could rotate the cam through quite a few degrees. So with that and the adjustment I could get exactly what I wanted. But Alan came up with an idea that I'd sort of brushed on but sort of discounted, and he was saying, yeah, to stop this wobble, why don't I machine down the outside face of this boss and leave some material on it, and then make a cam that'll fit over that sleeve and probably on the bottom of the valve lift where there's not going to be any pressure. I could drill and put the grub screw in, or once it's timed I could pin it, like I said before, I could pin it. But yeah, so it could be adjustable on that brass boss. So to reduce this boss down to a point where I can get a little cam on there that's going to do what we want. I don't need a lot of lift. Obviously this valve's only going to have a 1/4 inch of lift, so I've got to be careful if I make a cam that it's only going to have a small amount of lift on it. I think there's a bit of overlap as well. You sort of flatten the cam off at the top so it's up and it stays open a little bit longer. So good idea Alan, thank you for that, thank you very much. I think we're going to do that, I'm going to go with it. So yeah, obviously you've got an engineer in mind. So let's get on with it, and I'll start making this cylinder. Now, this liner, sorry. I was going to try and probably make the piston as well within this part, but they end up being too long at 40 odd minutes. Like last one, what, 46 minutes or something. It's too long, and unfortunately when you've got videos that long, people get bored, they skip through, they miss bits, and you'll get a comment and you can tell from the comment they haven't seen the whole video. So I'm going to try and make them as short as I can. So possibly we'll just do the cylinder liner, the top hat liner, and then we'll do the piston separately, because when you think about it, the piston's going to have cast iron rings, so I've got to make cast iron rings. I've never done a cast iron liner, I've never done anything like this before, I've never made an engine. I've rebuilt many an engine right up to V8s, I've done lots of racing, stock cars, you name it, I've done it, go-kart, messing about with go-karts and all sorts of stuff, and motorbiking, but I've never built an engine from scratch. So it was quite a challenge for me to have a go at it. So I hope you enjoy this part 5, and if you do, you know, there's all the thumbs up in there. Okay guys, let's get on with it. cutting a slug of the cast iron off to make the cylinder liner from. So that's a slug of cast iron to make the cylinder liner, as you've just seen me cut on the bandsaw. I've faced it off and I'm going to put a centre in there because I want this to be stable. Obviously it's got to be accurate, so I'm going to bob a centre in there. I've tapped it around because although this grip through chuck is quite accurate in the centre, it wasn't here, it was wobbling around, so I've tapped it around so it's within 5 thou, as I'll show you. So there's 5 thou wobble on there. So I'm going to bore a centre, then I'm going to start taking material off. I think possibly this end will be the cylinder head end where it's thicker, so it gets a trap in the bore of the housing. Then that's got to be bored to 1 inch to accept the piston. I'll do some checking on exact measurements when I start boring it. So what I thought was I'll take down the outside to either near or the finished size, and then I'll put a large bore steady rest, it's called. I can't put it on there now because this is rough cast and it'll be all over the place, but if I take that down, I can then put the steady rest on, I'm assuming. Now why do I want a steady rest on? Well, once I get this made to size, I won't part it off till last. I've left enough on this, it's 70mm plus enough to go in the jaws of air plus a little bit. I did cut it in error, to be honest with you. I should have left it 5mm longer, but it don't matter, we can get away with it. We can get around that. And then with the steady rest on, I can do the bore, which is obviously the most imperative thing. I mean, the outside, if you cocked it up, you could use Loctite, you could use all sorts of things, couldn't you? To bodge outside, you can never bodge the bore. The bore's the bore, so that's got to be right. So steady rest on it once it's bored to size, and that should hold it nice and steady so that we can bore the centre out. I usually thump these on, you can see what I'm doing. I thump at it rather than drive straight into it because they can wander around. If you gently thump them, you start a hole going, which you can probably see there. In this series, but this is a bit of a drawing. In the bottom here I drew the liner, and we've got it as 70mm long in total, and then we've got this little bit on the end which is 34mm diameter at the end, but the actual liner, well, I've got that as 32.23. Why I come to that I don't know, because the piston's 25.4mm. So where I got that figure from, not quite sure. Oh, I do know why. Because when I bored the cylinder, one cylinder, that's the cylinder bore size, 32.23. So if I make that 32.23, it'll be a press fit. And with Loctite and in the press, that should press in fine. Be careful, like, because if you start pressing something into aluminium and it picks up, you've had it. So to be very careful. So the first diameter is at 34, then down to 32.23. So if I get it down to, let's say 35, let's say 36, I'm going to write it on here on a piece of tape because I'm terrible for remembering things. So 36 millimeters. .23. Obviously I'll finish it larger than that and then probably sand it down. It's quite easy to manipulate. Right, I've had a slight change of mind of what I'm doing. Nice and cool. It's just tepid. So bearing in mind, we've got this counter bar here, so the barrel seals and the head can seal against it. As I bore this, I need to check it, and the only way of checking it is to undo the tailstock, pull that back and try the barrel on. Of course, if I machine the fat end here, the counterboard chunk here, I can't test it. So really I'm swapping it round, so the counterboard end, the thicker end, the seal of the top hat liner if you like, will be at that end. So I'm going to do some blowing up and some marking because I'm nearly down to my size. So I need to stop there. So move my stop out that I made. There's a YouTube video of that somewhere. Lock it nice and tight, so I can't go further than that. Okay, so now we need to reduce down to 32.23, and I said 34.4. Okay, we're done with that one. Let's move on. 32.23, but I'm not going to do it to that. I need to be doing it to 32. Come on, get your pen out and draw this and write it up right. 32. It needs to be 32.4. Yeah, 32.4. And then I can clean that up with a mitt cloth. Keep my eye on this now. When it stop, which you can't see down there. And keep an eye on it. This is a more than right. There we go. Bit of rust on there. That's it. Limiting factor, isn't it? Okay, right, that's got to be turned round. I have to put it the other way round. Is that because encroaching on my cross slide, the carriage? So start again. Right, so we're on 8, lever to the right. You can see that. That gives you 56 threads per inch. Let's double up on that and come backwards some. If we could go down to 28, that'd be lever in middle. There. much more. I've got to leave room in there for honing. So So we're actually 25.01 and we want 25.4. So we've 0.4 of an inch to take off, which I'm happy at that. I can do that with a honing stones. I can't part it off with this in. That's not We're going to be parting close to the chuck, so it should be okay. I did a video on this. When I bought it, it didn't zero when it was at zero, and I stripped it all down and repaired it. I didn't think I was going to be able to repair it, but I did manage. And I've never really used it. $128,000. $126,000. I believe that. 128,000. So it needs parting off, which is 3.28, which is what I measured, 3.28 millimeters. So if I part it off at just past 4, and then I can face it, can't I? What do you think? 4.5? Let's go 4.5 mil from shoulder. Stop it light. Oh God. Need to get one of them ordered. Remind me tonight, order one. Right. Look at that, we're a fraction out, that's all it was. One cast iron cylinder, quite a bit thick his wall, it needn't have been that thick. And 25, bang. Yeah. think I've put bore gauge down that it's parallel. I know my Myford cut's dead parallel, we don't have a problem with that, and I did run fine cut specifically for that reason. You put a hard cut down, your chances are you'll get spring in your boring bar. So that'll have some sort of sealant in there, whether it be Loctite or what, I don't know yet. Okay, and then the whole cylinder, the whole liner, I'll need a sealant on, or at least in there, so that it seals, because I don't want water leaking out, do I? Right. So maybe I haven't pressed that, because if I put that in press and press it now, it's in for good. That wants pressing later. I don't want to go in now. It's not ready for it. So that's the liner sticking out of the back. The piston will come a little bit past that. I'm designing it to do that so you can see it. We'll be drilling a hole down there for the oiler that'll go through the liner and be deburred, so that we can drip oil. And I'd also plan to the piston to have a hole in it right above where the conrod, at right angles to the conrod gudgeon pin, so it'll drip oil on the little end. Don't really need it, but I'd say that's a darn good success. So can you see it protruding? I mean, it's sticking out at the moment further than what I was telling you we're going to do, but that's because I haven't pressed it in yet, and I say I don't intend to. So I'm really chuffed with that so far, guys, and I think we're going to call it for part 5 of that, because there's no more I can do on that apart from drill the cylinder and the oiler, which I want to do later when it's all fitted. I'll drill that. So that's part 5 complete. Next part will be part 6, which will be what will it be? The piston, making the piston from this aluminium, and possibly the 2 cast iron piston rings. Okay guys, give us a thumbs up if you liked it. If it's too long for your video, don't worry, just skip through it. Skip through it till you get to bits that you might find interesting. If you don't find any interesting, obviously skip through a lot. But I know there's quite a few guys that are looking forward to seeing this complete build, and to be honest with you, so am I, because I'm still not convinced it's ever going to go. But you could say I don't know what I'm doing, and I don't know what I'm doing as in I've never built an engine, but I know exactly how an engine works, and timing and firing and all the rest of it, so we'll see where we go. Thanks guys. Alright guys, just to finish off this part 5 with our newly made cast iron cylinder liner. If anything, if I've got to be a critic of myself, if anything, probably the wall thickness is a bit on the thick side, but it don't matter, it's going to be in a little water jacket. Take the heat away better, it'll be fine. It's going to be, as I showed you just a few minutes ago, it's going to be a press fit into the main block, so I'm not putting it in, so there's no more I can do other than when my honing stones come, I'll hone it, get me exact 1 inch thereabouts what I'm after, and I'll probably put a little chamfer on the back edge here, which will make it easier when I push the piston in to get the rings in. The top don't really matter, I mean it's clean and I've stoned it well, I've papered it figure of 8, I'd do it a bit more, but the piston doesn't come anywhere near the top dead centre. These are only like 4.5, 5-to-1 compression, and I worked it out in the size of piston and the stroke, that we've got quite a gap of 5.5 mil I think it is, or thereabouts, before it's actually at top dead centre, where it is top dead centre. So your combustion chamber, if you like, is within the barrel, because the head is pretty flat that I'm going to make. I was thinking of cutting a combustion chamber into the head, making it thicker, and having a piston come at top dead centre, but I'm not. I'm going to go with tradition, which is what everybody else has done, and most of the big American ones I've seen, the piston never comes anywhere near the end of the barrel, way back. Okay guys, thanks for watching. Give us a thumbs up, and if you've not subscribed to my channel before, have a go at subscribing. Don't cost anything, and you'll get notified when I do the piston, which is next. So that was part 5. Next will be part 6, the piston. How many more parts there'll be I don't know, but I'm trying to make them more condensed if I can. I'm sure that's what people prefer. Okay, thanks. Nice and clean in there, no scratches. Happy.